Hey Bob, this is Dick Riley calling from Ophir Spiricon. I thought I'd give you a quick YouTube video, follow up on the graphics I just sent over to you on your email to help you get started a little more easily. Sometimes our instructions aren't quite as thorough as they might be. So if you can print out or follow along on your PC the graphics I sent over to you, there's about 18 slides. They're pretty quick, pretty simple. But it was easier to show you the graphics that you can look at, and then I'm looking at the same one. So when you open up BeamGauge, let me start with number one. So when you open up BeamGauge, you should have an icon on your desktop. Looks like a beam profile, sort of wobbly looking image, and it'll probably take the better part of 30 seconds for BeamGauge to properly open up. You'll get a banner on there that says BeamGauge Spiricon, and again, it'll take 10 or 15, 20 seconds before it actually opens up. On panel number two, when the camera comes up running, one easy way to confirm that it's operational is that if you look in the bottom right hand corner of your display screen on BeamGauge, you'll see a tab operating from left to right. This is actually the frame rate of the camera, and it should be moving from left to right at some speed, not particularly fast, operating as the camera is running. So it's a good visual indication that the camera is operating, collecting data, and I usually check that just to be sure, because if it's stationary and it's not moving, then that would indicate the camera is not operational, obviously. Number three, before we get to number three, as a follow-up on number two, the other thing to look at, just as a confirmation, on the left-hand side of your screen you'll see the numericals. These are your measurement values that the camera is collecting. And these numbers will be moving in a live fashion because it's trying to collect data, even though it's meaningless. But again, if those numbers are moving and active, it's a confirmation that the camera is fully operational. If you go to number three, if not, the first thing to do is to take a look at the Spiricon camera drivers. This is under your Start button, and if you click on your Start button, you'll see a Spiricon Camera Driver Manager folder that you can click on, and in that you'll see the SB928 camera, which is the one you have, and you can verify that the drivers are properly installed. If everything seems to be proper and you're still not getting an active camera, then give me a call. On number four, set the exposure and gain to minimums. When you look at the tab along the top of BeamGauge, this is where all your controls are located, and under exposure gain and black level tab you'll see there's three slide bars. You don't need to be concerned with the black level, that's the bottom of the three, but you want to be sure that exposure and gain are moved all the way to the left. One thing about BeamGauge is that we can always bring up a beam that is quite weak in power, but we cannot take a beam that's too strong and attenuate it through the software. That's got to be done through attenuators or mechanical beam splitters. So you want start out, put these at minimums, and you should be fine. Number five, activate the cursor to the centroid. This again helps to find out where the center of the beam is relative to your array. This is under your beam display tab. This is looking at panel number five, and in that, under cursor, I would select a centroid, which means the cursor is going to be located on the centroid of the beam, and it will find the center automatically. Number six, under computations, set your measurement value to millimeters. It probably comes up on a default under microns, and if you go up under computations, again on your ribbon across the top, you'll see beam width under computations, and you can change your beam width from microns to millimeters or to a variety of options depending on what's best for you. I typically use millimeters. You'll see that once you change that, it changes it automatically to millimeters and the scientific notation accordingly. Number seven, if you turn your beam on and position it onto the array, avoid going into saturation. Saturation with the BeamGauge exposure and gain all the way to minimums, this means the array is very sensitive, and you want to avoid saturation. Saturation, first of all, has no numerical values associated with it, and more importantly, if left on, you're going to damage the array, and that's the camera. heart and soul, as you might imagine. So if you're seeing, when you first turn it on and you're seeing saturation, then turn down the beam power or consider using an attenuator, but you want to stay away from saturation. If you look at the second graphic under number 7, this is a preferred image of a beam that is not in saturation. It can be less than this, can be all green or all blue for that matter, and those are different issues to deal with at a later point in time. But assuming you've got more power than you need, if you can stay in a beam image of this manner, then that's ideal. Number 8, set your manual aperture. The aperture is nothing more than a region of interest around the beam to ensure that the camera doesn't get distracted by making calculations with data outside the circle. Again, on your camera tab for beam gauge, go to aperture, go to circles. You have a variety of graphics. There's rectangles, there's ovals. I typically use circles if the beam is circular. And click on that. You'll notice on the following graphic a beam shows up in the upper left hand corner of beam gauge. If you click on the perimeter, you'll actually see the grab points of the circle, and you can move it and you can make it larger at that point in time. I would suggest moving the beam, the manual aperture. If you look at number 9 panel, make it about 1.5 times larger than the beam is itself and center it over the beam. Doesn't have to be absolute, doesn't have to be perfect, but reasonably over the center of the beam, and set the perimeter of the manual aperture about 1.5 times the size of the beam, and that's sufficient. Number 10, divergence. Going back to your beam gauge tab at the top of the camera, program under computations, you'll see divergence tab, and you'll see also in your numericals on the left hand side of the display for beam gauge, there's also a divergence numericals, so one and the same. This is the information you need to provide. On the second part of number 10, if you want to make things a little easier to read, in the upper left hand corner of your numericals there's actually an icon. I'm not even exactly sure what it's an icon of, but if you click on it, you'll get a panel that shows up that allows you to expand the graphics, increase the font size of the numericals to make it easier to read. And in doing so, obviously, then that becomes part of the permanent file. So in number 11, set the distance from the source to the array. You can set it up in milliradians or degrees. On number 11, if you go further under 11A, I've included a portion from our user manual that tells you how we actually calculate the focal length method that I'm referring to in this particular graphic. One thing to keep in mind, speaking of support and help, over in the right hand corner of beam gauge, it's not easily visible, and it should be more so, and it's extremely helpful. There's a dark blue question mark. It's a "what's this?" question mark, and if you click on that, you can drag it over most any icon or term in the beam gauge software program, and it will take you directly to that page in the user manual. It's a great tool. You don't have to have a paper manual at hand or electronic one and get out a beam gauge and go back and forth. By clicking on that and dragging that over and then clicking again on the topic that you're concerned about, it'll take you right to the beam gauge user page. If that doesn't work, or let's say it just takes you to the front page of the user manual, then that's an indication you do not have the latest Adobe Acrobat Reader program on your laptop. That's controlled by Adobe Acrobat, excuse me. So check on that, and because that's a nice feature to have available to you for quick and easy reference. Number 13, insert the distance. Talking about we're still dealing with the divergence. Insert the distance from the source to the camera array. Now the camera itself, the SB928 that you have, from the front surface of the camera, I'm not talking about the attenuator that's screwed on in that picture you're looking at, number 13, but from the face of the camera to the face of the array, it's 4.5 millimeters. So if the distance from your source to the face of the camera obviously is whatever, 3, 4, 5, 10 millimeters, then the 4.5 gets added to that, and that's your total distance from the source to the array, and that's the number that gets inserted into the divergence window in beam gauge. So if you look at number 14, I've just arbitrarily put in a value of 50 millimeters, and by doing so, I expand my divergence panel on the numericals on the left-hand side of beam gauge, and now I'm getting divergence values for X, Y, average, and radiancy intensity automatically. Number 16, just to begin to wrap this up, when you save data, just go up to the beam gauge icon in the upper left-hand side of the screen, click on it, and you pull down to save data, and it's all right there, and you can save it wherever you should want to at that point. Number 17, this is a supplement of setting power to the to your readings. Cameras are not power meters, they're cameras, so you have to calibrate them for power. But with the beam on and your aperture set, you can go into computations again, go over to the power energy tab, insert the amount of power that that beam represents. You'll need to know what it is in advance, and then by clicking the X right below it in the same panel, we then get, and I put in 5 milliwatts just as an example, and then my total power, peak fluence, minimum fluence all get activated as a function of power density based on 5 milliwatts of power in the panel below. One other aspect I wanted to add under number 18, you asked about power in the bucket. Again, here's the page in the electronic manual, Encircle Power Methods. We have several that you can choose from, and also a comment from Del Olson, who's our customer service manager. Actually, he would be the one, if we don't see the camera, I would get in touch with him immediately, and you see his phone number, and I didn't include his email address, but his regular phone number and cell number. But take a look at that. So when you're going back to the power in a bucket, under, again, computations, there's a small little tab arrow in the bottom right hand corner of that window, and when you click on that, these are various measurement values that need to be set if you're going into that kind of measurement as it affects your power measurement. So and again, using the what's this question mark, you can learn more about that particular aspect. So any questions, give me a call. Hopefully this helps getting you started. I think you've got a pretty straightforward application. As I say, key things: stay out of saturation, see what sort of measurements you're getting. Hopefully we can get the whole beam onto the array. You've got a very fine pitch on that array of 3.69 pixels, 5 by 7 millimeter array, so it should work satisfactorily. So any questions, let me know. Otherwise, best of luck.